In the last session, we had discussed the burning of magnesium ribbon and the reaction of potassium iodide with lead nitrate. And those two reactions we have observed there is a change in state of the reactants into products. In the case of magnesium, it had formed a powdered product. Whereas in the case of reaction of lead iodide with potassium iodide and lead nitrate, they had given an yellow precipitate. Once let's get a clear explanation about the chemical equation. Let us recover the activity 1.1. When magnesium metal is burnt with oxygen, when magnesium metal is burned in oxygen, it gives magnesium oxide is the definition that we got after burning the magnesium ribbon with oxygen to form magnesium oxide. We want to say this is the chemical equation that was given in the form of sentence. But every time we cannot write these chemical equations in the form of sentences. So to make it in a simple way, we can write the whole equation in the form of a word equation. In the form of sentence writing, we can write the same in the form of a word equation. Here, when we are writing the word equation, we will take the reactants or the products, whatever the substance it may be, in the form of the words. Here, in the equation, once we had seen previously, magnesium is burned in the oxygen to give magnesium oxide. Means when we are going to use only word equation, we will take the words of reactants and also the products. Let's see here, word equation we can write as magnesium is one of the reactant. It is going to combine with oxygen, that is the second reactant. So these reactants are written in the form of the words. And the product is magnesium oxide. So the change of one substance to another substance was indicated now with an arrow that is indicated towards the right side. This indicates that the reactants are going to be converted into products. So in the word equation, we represent only the words, which makes the work simple. Now we are going to give further simple way about the meaning of a chemical equation. The words, whatever we had used for the reacting substances or for the product substances, we will use their chemical formula. We will use their chemical formula. So the word chemical equation is the short notation of reactants changing into products. It is a short notation of reactants changing into products using their chemical formula for the elements or compounds. So what we can define the chemical equation is? Chemical equation is the short notation of reactants changing into products using their chemical formula for the elements or compounds. Means magnesium, once we take, we can use only its symbol. Mg is the symbol for magnesium. Oxygen is an diatomic, so we represent as the O2. Magnesium oxide, we represent it as the MgO. So the chemical equation, it is going to represent the chemical formula of the reactants. What are the reactants here? Magnesium and oxygen changing into products. What is the product that is formed? MgO. So a chemical equation is the shorthand notation for the representation of the change of reactants into products. So now we are going with the seeing expansion for the topic, that is the chemical equation. Previously that we had written in the form of its formula, we must make it in a balanced state. That is from the law of conservation of mass that we have learned in the grade 9th standard. It explains that during a chemical reaction, the mass of the reactants will be equal to the mass of the products. Means the number of reactants will be equal to the number of products. Let us take the activity 1.3 equation that we had studied yesterday. We can remember that activity when zinc granules were reacted with dilute sulfuric acid. The products formed were zinc sulfate and also hydrogen gas. Here, once we see, how can we say the equation is a balanced state? First, we must calculate the number of atoms that are present on the left hand side. The left hand side is the reactant side and the right hand side is the product side. So first we will take what are the elements that are present in the chemical equation, and we will calculate the number of atoms that are present on the LHS, and we will check the number of atoms that are present on the RHS. Means whenever we are going to balance a chemical equation, first we need to form a tabulated data. And now we are going to see what are the elements present in this reaction. We can find on the LHS side. First we can find the zinc and we can find hydrogen, we can find sulfur, we can find oxygen. On the LHS side, the number of atoms of zinc are how many? We have only one. And on the RHS, that is the product side, the number of atoms of the so-called element zinc, how many we find? Only one. So what is the next element? We find the hydrogen. On the LHS we find there are two hydrogens on the LHS side, and on the RHS side also we find the hydrogens are two. Coming for the next element, sulfur, we can find there is only one sulfur, and on the RHS also there is only one sulfur. Coming for oxygens, we can find there are 4 in number, and on the RHS also there are 4 in number. So when can we say it is a balanced chemical equation? We can say it is a balanced equation when the number of atoms on the LHS, that is reactant side, are equal to the number of atoms on the product side. This need to be satisfied to confirm the law of conservation of mass. That is, during a chemical reaction, the mass of reactants will be equal to the mass of products that we have learned in the grade 9th standard. We will take up one more example now. So, we are continuing with the example number 2. Our example is when iron is going to react with steam. Steam means the water is present in the gaseous state. The reaction we are representing that iron is going to react with steam. The products that are found are Fe3O4 plus H2. Do we find this one like our previous example? Let's take. On the LHS, that is on the reactant side, we find only one iron, whereas on the product side, that is RHS, we find there are 3 irons in its formula. On the reactant side, we find hydrogens are 2. On the product side, we find hydrogens are 2. We think they are in a balanced state. Let's check the next third element. We find here in the compound of water, there is only one oxygen. Whereas on the product side, in the compound of the Fe3O4, there are 4 oxygens. Now we say this is not a balanced equation. Then what are the steps we need to follow for balancing the chemical equations? So we are taking the steps to follow. There are approximately 7 steps that we use for balancing the chemical equations, and among them we are still observing the step 1. What is the first step to do? You write the chemical equation as it is with representing the given elements or compounds surrounding them in a box. In the given equation, we find the reactant Fe and we give a box around it. Next, another reactant is H2O. So write the same compound H2O and surround a box around it. And write the products Fe3O4, give a box around it. Write the H2, give a box around it. So step 1 is write the given reactants and products in boxes that we have done. Now the step 2 is write the equation again, but you find what are the elements present in all overall chemical equation and identify the number of atoms of each element present on the LHS and also on the RHS. So according to the equation, the table A, the elements and find the number of atoms on LHS and RHS. our second step to do. So let us take the elements that are present here. What are the elements that are present in this equation? We find iron, we find hydrogen, and we find oxygen. So we are going to see the number of atoms on the LHS now. LHS is nothing but the reactants, and we are also going to find the number of atoms on the RHS. Number of iron atoms, we give a table. Number of iron atoms on the reactants. How many we find here? Only one. And on the RHS, how many irons we find? 3. How many hydrogens we find here? 2. How many hydrogens from the products we find? 2. And how many oxygens we find here on the LHS? We find only 1. And on the RHS we find 4. How to start balancing this unbalanced equation using the second step? You choose the element from the compounds that is having maximum in number. In the whole table, once we see on the LHS, iron is only 1, product side is 3. Hydrogen on the LHS only 2, RHS is also 2. Oxygen, LHS 1, RHS 4. So what is the element that is maximum number? We find the oxygen on the RHS, that is maximum in number. Means first we will start using balancing the oxygen. Let us do that in the step 3. So according to the second step, what we are going to do. So let us see what is the second step we concluded. Once again we are recalling the point. In the second step we had observed the oxygens are 4 in number on the RHS, whereas on the LHS they are only 1 in number. That is what we are making the third point highlighted. Find the atom that is maximum in number on reactant or product side. We have already identified the atom is the oxygen. Then balance it on both sides. So the element that we had identified is the oxygen. Initially, in the second step will be our equation under consideration. Number of atoms on LHS. Number of atoms on LHS. How many we had? We had only 1 oxygen. The same number of atoms on RHS. How many we had find? We had find 4. So these 4 are present in the formula Fe3O4. Very important point, children. When you are going to balance the number of atoms, you must not change the formula. You must add this number to be the prefix of the formula, or we can use the word coefficient for the formula. Let us see here. Fe3O4 on the RHS there are 4, but on the LHS there is only 1. So in the balanced equation, the oxygen atoms must be 4. That is already existing. What is there? So 4 ones are 4. So number of RHS will be 4. Now how the equation will be? Once we will have a glance. Every time place it on a box. So let us see the equation now. Equation will be written as Fe plus H2O gives rise to Fe3O4 plus H2 is the equation. So the number of RHS and LHS must be equal. That is what we had find. We must not change the formula, but we can bring the number as the coefficient. Here 4 is there. We cannot write 4 here. Please don't do that mistake. So bring the 4 as the coefficient. Now the total equation will be considered here.